If you haven't done already, when studying mathematics, you will eventually come across Venn diagrams. This video is a brief introduction to Venn diagrams. A Venn diagram is a way of showing mathematical sets using overlapping circles, within a boundary representing the universal set. And to understand what that means, we're going to look at two examples. Here's the first example. We have a set of numbers. They are the integers from 1 to 10. For this example, we are going to call this the universal set, as indicated by this symbol. From this universal set, there are two other sets, A and B. Set A are even numbers. So for this set, that is 2, 4, 6, 8 and 10. Set B, those numbers in the universal set that are factors of 6. So that's 1, 2, 3 and 6. Notice that both sets are in curly brackets, which is the general way in mathematics for presenting sets of numbers. If you remember from the previous video on functions, the sets of numbers that make up the domain and the range were also in curly brackets. So these two sets of numbers are taken from our universal set. Notice that 2 and 6 are common to both sets A and B. I'm now going to create a Venn diagram to show this information. We begin with a rectangle which will represent the universal set. I'm now going to draw circles to represent sets A and B, and in those circles I'm going to write down each set of numbers. Notice how I've drawn them. They overlap. This is because of the values that are common to both A and B. So that's 2 and 6. Let's put those in where A and B overlap. I now need to add the remaining numbers for both sets. So for set A, what we have left is 4, 8 and 10. And for set B, we have 1 and 3. But we are not quite there. There are 3 numbers in our universal set that are neither in sets A and B. Those are the numbers 5, 7 and 9. These numbers go here. They are positioned within the rectangle, the universal set, but outside of the sets A and B. Let's use this example to look at some notation you might come across when working with Venn diagrams. Here we have A, and with what looks like a U, and B. This is the union of sets A and B. That is, it contains all the elements of A and B. So this is 1, 2, 3, 4, 6, 8 and 10. You might also see this. This time the symbol is the other way round, and it looks like a small n. This means the intersection of A and B. So that's 2 and 6. You might see something like this, where there is a dash next to the set. So in this case we have A dash. This means the complement of set A. That is, any numbers that are not in set A. So that's 1, 3, 5, 7 and 9. The complement of B would be 4, 5, 7, 8, 9 and 10. You might also see something like this, with a small n. In this example, this is telling us how many elements there are in set A. In this case, there are 5 elements. 1, 2, 3, 4, 5. The number of elements in set B is equal to 4. The number of elements in the intersection of A and B is 2. And if we consider the number of elements that are not in A, there are 5. We might also want to work out the probability of randomly selecting a particular value. So if we wanted to work out the probability of, say, randomly selecting a number that is a factor of 6, then this would be the number of elements in set B, which is 4, divided by the number of elements in the universal set, which is 10. Notice that the notation for finding the probability is a capital P. So the probability is 4 over 10, which simplifies to 2 over 5. If we wanted to find the probability of selecting a number that is in both sets A and B, well, there are 2 elements in the intersection, so the probability is 2 over 10, the number of elements in the universal set. And this simplifies to 1/5. Let's look at a second example. You might get a question that looks something like this. 50 students were asked if they were planning on studying mathematics or science at college. 25 students said that they were planning on studying mathematics. 8 said that they were planning on studying both mathematics and science, and 4 students are not going to study either subject. Part A. Draw a Venn diagram to show this information. Part B. What is the probability of a student studying science? For Part A, let's draw the Venn diagram. So here's our universal set. Here is the math set. And here is the science set. Notice that they overlap because some students are planning on studying both subjects. Let's fill in what we know. Starting with the intersection. There are 8 students that plan to study both subjects. If I subtract that 8 from the 25 that plan to study maths, then that means that there are 17 students that are planning to study maths only. There are 4 students that are going to study neither subject. So we need to work out how many students plan to study science only. If we subtract 25 and 4 from 50, the total number of students, we are left with 21. So that's how many students plan to study science. But we need to work out how many plan to study science only. And that is equal to 21 subtract 8. Remember, 8 is those students who plan to study both subjects. And this is equal to 13. And there is our completed Venn diagram. Part B says, what is the probability of a student studying science? So the number of students studying science is equal to 21. So that's 21 out of 50. So 21 over 50 is our answer. So to summarise, a Venn diagram is a diagram in which mathematical sets are represented by overlapping circles within a boundary representing the universal set. This is the symbol for the universal set and is represented by the rectangle in the Venn diagram. The elements in a set are shown in curly brackets. This symbol here means the union between sets, so in this case that means all the elements of both sets A and B. This symbol means the intersection, so in this case this is the intersection of A and B. The dash stands for the complement of a set, so what that means is if we have A dash, so this is everything that is not in set A, and B dash would be everything that's not in set B. The N is used to notify how many elements there are in a set, and the capital P stands for the probability. So this is asking what is the probability of obtaining a value that is in both sets A and B. There's an introduction to Venn diagrams and some of the notations used. I hope you found the video helpful, and thank you for watching.